Okay, welcome to our weather discussion. We finally have some rain coming. It doesn't happen much this fall, hasn't happened much this fall, but it will finally happen over the weekend's already started now. So we'll talk a lot about that. We'll talk a little bit about where we've been over the last couple of weeks, weather-wise, not only here, but some aspects of global quantities. And then think about some storms that are remote from us but are nonetheless interesting. So that's where we're going to go today. So we're looking right now at a one-week satellite image. When it gets back to the beginning, it will be Friday at about the time we meet from last Friday, and then going every 30 minutes, I think, isn't it, Pete? I think it is.
Those are every 30.
Every 30 minutes for a whole week. So you get a recap. This will be last Friday. So we had some pretty nice weather last week, as you might recall. It wasn't true everywhere around the country. We had a cyclone just to our south, which you'll see as the clouds come in the day on Sunday. They kind of dissipated. Didn't really do much over us. That storm kind of dissipated as it moved to the north and east towards southeastern Canada. And then we had 3 days in a row where we had 70 degrees or higher, November 1st, 2nd, and 3rd. And I thought to myself as that was going on, we'll talk about a tropical storm Martin that turns into a really extreme extratropical cyclone late in the week. That's one of the things we'll talk about. And then here's the weather that's looming over us right now. We'll say something about that. But the 3 days in a row, over 70 in November, I thought maybe there's a chance that's a record. So I went back and looked, and there's a great site that Scott Lindstrom pointed me out to many years ago. The Weather Service has a bastardized version of that. You can't do all of the same things on the Weather Service version of it at the Milwaukee page that you can on this other one. So we've had 4 particular events where we've had 3 straight days or more in November where the temperature's been above 70. One of them was in 2008, one was in 2015, and then we had the one we just had this week. But does anybody remember the other one? And it's the longest streak ever, 5 straight days. Bella?
2020.
It was 2020. I was asking around yesterday among friends and people here at work. Nobody could seem to remember that. I didn't. I was surprised when I found it. How did you remember that?
We talked about this yesterday.
Oh, come on. All right. So did anybody actually remember that? Because during that time is when, you know, after the election in 2020, there was a period of time nobody knew the answer. And it was on the Saturday the 7th, which was the middle day of the 5-day streak, where we found out who won that election.
I was gonna say, I remember it was election week
Yep.
because everyone was outside, like enjoying the nice
That's
weather
right.
after
Oh, yeah.
the election
Yeah.
got called. So.
Isn't that funny that other than that, I had no recollection at all of that. And then when it occurred to me that it was that weekend, I thought, oh, of course, yeah, I do remember that now, the same thing. So 5 days in a row, 5th, 6th, 7th, 8th, and 9th of November, 70 or above. That may never happen again, although on the other hand, it's happened 4 times since 2008 and never once before that. So, you know, speaking of elections, we've got a guy up for running for the Senate, and I don't care if I tell you what my preference is. I don't want the guy who's currently the senator to win, because he thinks global warming is, quote, BS. I won't use the word he actually used in front of voters. It's not. To get that kind of a weird streak only in the 2000s is saying something about what's happening around the globe. And, you know, it's not the only thing that leads one to that conclusion, but it is a piece of evidence that's really hard to, you know, argue against. So that's interesting. Let me show you this. We've just, go back into all of these things. I like to give you an update of this every once in a while. It tends to be once a week, I guess. I know that I'm getting to be like a broken record. This is November 3rd. So through November 3rd, the 850 millibar cold pool. Remember we had this kind of period where it just got flat. We had 3 record warm days ever, and then I've returned to normal, and then another dip, and so on. So that's where we are now. This is the 10th warmest September 1st through November 3rd in the last 75 years from the NSEP/GFS data. And October was the 9th warmest October. That's a lot of departure from normal. We almost never had a normal day. We had one normal day, October 1st. After then, maybe October 25th or so. After that, everything was below normal. And this coincides with some really stunning records around the globe that you may have heard about. I think Europe had its warmest October ever. Now, I don't know if that means every country in Europe as an aggregate or how exactly that's done, but France had never had a 90-degree temperature day ever in October until then. Same with Germany until this year. And there were a few other things I wish I'd written them down. Maybe you've seen some of the stories. but extremely unusual weather around the hemisphere in the month of October. And at least one place where it registers is this weird little measure, and this is the 9th warmest October of all time. The warmest ever was 2005, of which I have zero recollection. I don't know what that was like here locally, or whether there were any kind of weird stories around the rest of the northern hemisphere. But anyway, that's kind of cool, what's going on. So let me show you a few observations that are going on currently. I'm trying to run this whole thing from my new laptop that Pete has helped me to put together and get it working, so it'll just take me a little bit. I probably have it open somewhere else, but I didn't really pay much attention to that. I want to go to our Weather Watch links, and let's take a look first at the local in time satellite movie. We'll do it in color. I like that color visible. So here's what we have currently across the continental U.S. and adjacent waters. Let me point out first, it's hard not to see this feature. This is extratropical cyclone Martin, which is now southeast of Greenland. What an impressive storm. I think central pressure is down below 940 millibars. It occupies the entire Greenland Sea, and of course stretches all the way almost to the British Isles in terms of its influence. And then all of this low-level stratocumulus is simply the cold air that's being funneled off the continent over the ocean in the northeastern part of the Atlantic. So that's what the heck is the name of that ocean? I'm trying to think of the name of this. Just escaped me. Labrador Sea. So this is a place where the North Atlantic convection can be really strong, and I've always wondered if it isn't largely a function in the wintertime of just cold air coming in, cooling the surface and forcing that water to sink. And that drives the thermohaline circulation to a large extent. Every time I say that to an oceanographer, they look at me like, no, that's not really it. But then they've never been able to tell me why I'm so far off track. So there must be something to it that perhaps they've neglected and I overemphasized. So some combination of the two might lead to a little bit more insight than either of us has to begin with. That's not asking much for me. I have almost zero insight. And then we saw on the satellite movie, Tropical Cyclone, what was it called again? Lisa. Was quite an impressive storm when it was in this is the Bay of, no, not Bay of Campeche. It's just off the Yucatan Peninsula to the east. This was a really intense storm. It moved across the high terrain of the Yucatan, and it still has a semblance of a structure here now in the Bay of Campeche. Very impressive, soldiering on. And so I don't know, and I'm not going to pretend that I care what's going to happen to it next. I honestly don't. We're in early November, and I'm done with the tropics. I don't care anymore. But I do, of course, have some concern for the welfare of citizens who might run into this thing if it does get to reorganize. But you can see there's some really heavy convective towers blowing up in the middle of that thing, and it still has an obvious counterclockwise swirl, even after coming across the Yucatan Peninsula. That is something else. And then here's the cloud band with which we're contending right now, and it's just begun in the last couple of hours to precipitate over us. But you can see a little bit of hint about what's going on here in the geometry of the clouds, helped a little early on in this image by the shadow. There seems to be a little bit of a hump developing in these clouds, and that's known as a baroclinic leaf. It often is the first way that a pre-existing cloud mass might indicate that there's development going on to the south and west. And we'll see there's really good reason to believe that. And then we'll trace a little bit of the developmental mechanism of that, which leads to continued, probably intensifying rains for us over the next 24, probably 36 hours. And that's tied to development and pre-existing frontal boundary that is going to become active. It's not particularly active now, but it's going to become more active as time goes on. Okay. And then I haven't looked at the Pacific satellite movie yet. We'll do that together. Okay. So those are some of the broad features I want to comment on. We'll also look at a long life satellite movie of Martin in just a second. So let's first go to the Pacific. I'll look at the infrared and just see what's happening in the Pacific in the last several hours. So ITCZ down here, giant gap and some flare up around 160 degrees. And then notice the pretty much zonal flow from nearly the dateline. The dateline's about here, it's 180. So it's 160 all the way across at, 45 degrees or 40 degrees north latitude. And everywhere to the west of that, a plume apparently of tropical influence coming up into this cyclone here at the south of the Aleutian Islands. And then we can't see much more to the west, although it seems to indicate that there's more activity further to the west. Complete absence of big cyclones this fall in the eastern Pacific Ocean at mid-latitudes, which is a little disappointing for me, but is really interesting nonetheless as a scientific issue. One imagines, and we can maybe verify this, that the jet in the Pacific, which is often aligned in a more zonal orientation and kind of is limited to longitudes to the west of Hawaii, has just gone crazy pointing poleward and extended as it's poleward. And that is really interesting. What drives these interseasonal variations of the orientation and intensity of the Pacific jet is a really hot research question. Maria Madsen just had a really nice thesis about a year ago on that, on aspects of that, and we're going to continue thinking about that. But to the south of what might be a jet core, there's a convective cluster north of the state of Hawaii that has a clockwise rotation to it, clearly divorced from the ITCZ, but doesn't look exactly different from it, except one gets the hint of some rotation because it's in the subtropical mid-latitudes. And then there's this really nice little, perhaps polar low coming off of the Bering Sea right here in the western part of Alaska. I think we're seeing this in a sort of a shrunken scale. It's probably a little bigger in scale than it actually appears on this image because we're at such high latitude. But that's a really pretty cyclone of very small scale coming off of the coldest part of the ocean there in the Bering Sea. So that is probably a polar low, and I wish I'd seen that before. I might have tried to find an Alaskan satellite image. They do have them at the Weather Service.
I've got some on ArcGIS too.
Oh, you do, Alaska?
If you go to the GOES 17 page,
Okay.
all of the GOES 17, so scroll down,
Yeah.
and where it says all GOES West images,
Oh, yeah.
and then on that page, to the right,
Right there.
there you go. So only every 10 minutes, because that's all we get up there, but.
Only every 10 minutes, Pete? Come on. So here's 12 hours. We get maybe a little bit better view in a longer time scale, but look at that. I don't know what this, I know that, I used to know the name of this island. I don't know what it is off the top of my head now. But right to the east of that is the development of this really high latitude polar low type disturbance. I wonder if that's actually what it is. Could be fun to take a look at that. So that's a nice little disturbance. Probably, of course, bringing snow to some of the southeast Alaska. It's cold enough at this time of year for that to be a reasonable expectation. So there's always something interesting to look at. I mean, if you can't find something interesting in the weather, I think you've got bigger problems than that. No, I shouldn't have done that. I needed that page. Well, the next thing I was going to do is look at the national radar, so sorry, I wasted your time here on that. So let's take a look at the national radar. And of course, the feature of interest right now is this precipitation band that stretches all the way actually from Green Bay or northeast of Green Bay down to the Red River in Texas and even further south than that. And along the line, it gets kind of lit up with some pretty intense convective cells. You see them really reforming and then, first forming and then reforming along this line in Texas into Oklahoma. And it gets a little bit wider distribution, but even within the wider distribution, one sees pockets of enhanced convection, which also have, I don't know if I'm seeing it or imagining it or not, but just little bits of rotation in each of those. So it's a complicated precipitation band across the central United States right now. And it's got it's really interesting complications in the state of Texas. But you can see, not far from us, there's probably been a rumble of thunder down in Kenosha, maybe in Milwaukee itself, not quite over us. And so the best is yet to come, it looks like. It'll be a rumbly afternoon with occasionally moderate, sometimes even heavy rain showers. All of this is occurring in the context of a pre-existing frontal boundary across the central United States, which I'll show you evidence for in a minute. That's tied to a decaying cyclone up in central and eastern Canada. And then on the southern side of that frontal boundary, there's a new development that's beginning to get itself organized in central Texas. And it will kind of be a stunningly rapid development, although then suddenly cut off in terms of its further intensification over the next 24 hours. So a really interesting weather scenario developing over the south central United States, and it will impact us for a full 36 hours. And then you can see here, we've got precipitation all the way offshore in the west coast and then coming into the Puget Sound area. The Cascades are right about there, and that's why you don't see anything to the east. And then you've got a radar at Pullman and a radar down here in northeastern Oregon, and in between you don't see too much. That's probably a real rain shadow, because the flow is pretty much zonal, and the cascades are oriented like this. And so onshore flow will produce some pretty decent rains, and then there's a shadow, and then you get some more downstream of that. But that's really the main feature in the across the continental U.S. right now. So let's take a look at some upper level charts, courtesy of Super Pete. I can just do that right here. I don't need to go to that page anymore. So I want to first show you the 500 millibar map that's current right now. And here's the 12Z 500 millibar map. So here's the broad scale picture. We've got a trough with embedded short waves, one of them off the British Columbia coast. That's fairly intense. Look at the horizontal temperature contrast with that. Strong cold advection right on the backside, and then zero advection here, so there's differential temperature advection. That's probably part of the reason why there's a tendency for air to be rising on the one side, and that was seen in the satellite picture with the clouds streaming across and in the zonal direction. This is a little bit funny angle, but it's a zonal direction, and then coming onshore in Washington State. And then the second short wave is the one over Arizona, and that's a much sharper wave. And over central Texas, you're right downstream of that feature, and so this is a prime spot for reasonable possibility for development at the surface. Now, well downstream, the flow is perfectly straight. So all of the subgeostrophy in the trough is not met with supergeostrophy in any downstream ridge. That tends to mean that the ascent associated with the ageostrophy is very locally confined to the position of the trough. If you have a trough and then a downstream ridge, you're going to have a broad region of ascent and pretty strong ascent. But not in this case. It's going to be really locally confined to the New Mexico-Texas border, I think, because there's no downstream ridging. And then if you look again further to the north, then over the Central Plains, where there doesn't seem to be too much in the way of confluent frontogenesis. It's not zero. The flow here in western Nebraska has a different orientation than that does in southeast Kansas, just a little bit. There's a little bit of confluence and some temperature contrast you can see in the isotherms. So that's tending to intensify the gradient by the influence of the horizontal advections, and that will produce ascent on the one side. Remember, we had a precipitation band from northeast Iowa, actually Green Bay, all the way down to central Texas. So that's all on the one side of this modest mid-tropospheric frontogenesis. And some of that is in the region where there's development perhaps ensuing, or actually occurring, in West Texas. So that's what it looks like at 500 millibars. Okay? And then we have a cyclone that's tied, I think, originally to this upper wave that was that's sitting over Hudson Bay, and that's where the whole baroclinicity in the lower troposphere is coming, is associated with. And finally, there's the complex at 500 millibars, its manifestation of Martin. And notice that it is, I think that's a warm core. I think that's warm 500 millibar temperature right there. So that's an interesting structure. We could interrogate it, we won't, because I might be wrong. It's equally likely when one finds an upper level geopotential height minimum that it's got a cold core. I'm just guessing that maybe that's warm. It's not got a number on it because of its origin. So I don't know if I'm right or not. But it's very intense. You only have to go to 5 kilometers to find the 500 millibar level southeast of Greenland. And that's because this is a really intense disturbance. Let's go a little bit lower, 700 millibars. And this is the often neglected 700 millibar map. I like to look at it a lot of time because it tells you a lot more about the thermal structure. And if you're in the cold season and you've got active frontogenesis going on, you can see it sometimes better at 700 millibars than you can at 5. I think that's definitely true in the northern portion of this region. Notice the confluent flow. It's zonal flow across the Dakotas and then southwesterly across Illinois and Wisconsin. So there is a tendency for the flow to contract, or to intensify the gradient of potential temperature. And again, the response is always, when it's intensified, to produce a thermally direct circulation, consistent with what we saw on the radar, with warm air rising, producing clouds and precipitation. And further south now over New Mexico itself is where the trough axis is at 700 millibars, indicating again the same location is under the gun for development, West Texas, West Central Texas. Okay. And then one can see perhaps a little bit better the relationship between this cyclone and the trailing baroclinic zone, especially up here in northern Quebec. There seems to be a really strong baroclinic zone, perhaps tied to this development. And there's Martin at 700 millibars, only 2.3 kilometers above sea level. And finally, 850, well, it won't be finally because I want to show you one more. But this is 850, where the lower you go in this case, we started at 500, then 7, and now we're at 850, the baroclinicity and the frontal characteristics are stronger and stronger and stronger with this feature that drapes across the central United States. Look at this, for instance, between Kansas and Oklahoma. 14 degrees temperature difference between this station north of Oklahoma City and western Kansas. So it's +1 there, it's 15 there, and the wind shift is 180 degrees. Maybe even more than that, it might even be 190 degrees. Okay, so that's a really sharp temperature contrast, extraordinary horizontal shear, and one guesses without doing the analysis, because it's a frontal zone, it's going to also be a really strongly statically stable layer, wherever the front actually is. So this is pretty intense. One thing I don't notice in the middle portion of this is any tendency for those winds to be strengthening the horizontal temperature gradient by differential advection. So those in 452, 751 know that vorticity itself, though it's a characteristic of fronts, has absolutely no role to play in the intensification of the horizontal gradient. And that's a curiosity, but it shows up here in a dramatic fashion. Really sharp shear, but those winds are not doing any differential temperature advection. It's almost a textbook example of the fact that the vorticity is rather impotent in terms of intensifying the gradient. But if you go a little further north of the Iowa-Minnesota border, well, suddenly we've got confluence again. And we saw in the satellite the clouds are pretty well structured all the way up there. Here's the cyclone in Hudson Bay. Nice warm frontal structure that Wen and Alcin talked about yesterday in class. And then here is the trailing cold frontal structure, much of which is active with precipitation. But I bet you the frontogenesis is contained in the middle and upper troposphere, not so much at the ground. And that's an interesting characteristic of this event. But it would require further analysis. So what I want to do next is just show you briefly the satellite loop of Martin as it gets itself wrapped up. I won't say any more than just show that to you. And then we'll look at some of the instantaneous surface observations across the central U.S. You hate to miss a really strong frontal passage, so we're going to do that. And then we'll talk about the development that will ensue. Okay, so that's the broad plan. So let me first show you the satellite movie. I think I've got that saved here somewhere. Yep, here's the Canadian Meteorological Center satellite movie. And this goes all the way back to 2nd of November at 12Z. So that was what, Wednesday? And it's, I forget, it's in a really high temporal resolution, but here's the image as it goes. So there's Martin. It never really looks like it's strongly a tropical cyclone and not an extratropical cyclone, but there is an eye, clearly. And I trust that the hurricane people absolutely know what they're doing, of course. I don't have any doubt about that. But it's got a trailing frontal boundary that looks like that, and they had an initial warm front. So it always had a flavor of an extratropical storm, though it was clearly tropical at some point. Look at the latitude. This is 40 degrees north, okay? This is weird. And to get you situated, Newfoundland, Nova Scotia, New Brunswick, and there's the United Kingdom, and this is the southern tip of Greenland, right there. So there is an initial storm, as you can see up there. This is Martin going up into that region. So there was a pretty decent storm in the Labrador Sea, big cloud shield between the two, and it looks like, well, what happened to the storm? Here on, there's a time thing on the top. I'll slide down so we can see the time signature. So 4th of November, early this night, but watch what happens now. Now the thing's getting really revved up. There's no storm along the west coast of Greenland anymore. Everything's consolidated into this. I'm not so sure watching this, though, that there wasn't some combination of the two disturbances that led to the final product we see right now. But I don't know any more details. It just kind of looks like that. So just to highlight again, cold air streaming from high latitude off of Greenland and the Greenland Sea to the west of Iceland. There's just one little sort of open cellular convective wave after another. Ireland, the west coast of Ireland's a place to go right now. Man, it's just one after. Look at this little disturbance here wrapping up. This one wrapping up towards Scotland. What a place to go right now. And so here's storm number 1, right? It's seemingly independent circulation just south of Greenland. And then here's Martin, and the eye is kind of gotten a little bit lost, but it's definitely got a connection to the tropics that's very convectively active. Big cloud shield between the two. This is cloud shield from storm number 1. Then they kind of amalgamate, and for a while it looks like there's no particularly strong circulation anywhere. And then suddenly Martin reemerges, or whatever we want to call this thing, reemerges, clearly with like a warm frontal type structure, a cold frontal type structure, and a cyclone center in the middle. So, like I said, I don't have time to to analyze this right now, I didn't have time this morning, I should say, but I would be looking at vertical cross sections through that. What's the thermal structure? How did it evolve? Those are the questions I want to know. Okay, so pretty cool. And never neglect the Canadian meteorological satellite imagery. North Atlantic, you can see all kinds of cool things that you just can't see, despite the ones that we get from GOES. And Pete does a great job making them. These Canadian ones can really bail you out when you want to look at something.
That is from GOES.
It's not the sector that we get, I guess I should say, yeah.
Right.
You're right, it is
That's
from
the
GOES.
same kind of imagery we were looking at for Alaska.
Yeah, so it's really fantastic. Okay, now I want to look at some surface obs. And I did a little not fancy, just basic analysis on them, because I wanted to show you something that I found in that. Now, where is that? I guess I'll just do it this way. There we go. Okay, so here's the 15Z surface obs across the central United States. I hate to let a strong cold front go by without looking at the surface obs. So look at this, 63 over 54. Several people were complaining how muggy it is outside. Correctly, it's miserable, right? Pressure rising rapidly, pressure falling at Milwaukee. But then look at it, just across the river, 46 degrees, 39 in Minneapolis. Go further south, 67, mid to high 60s in Illinois. 41 in heavy rain in central Iowa. 40 moderate rain, heavy rain at this location, and then light rain, temperatures in the 40s going down into the 30s. That's the case all the way down across the central U.S. In fact, why not try to do an analysis on it? So here's the frontal boundary. This is the cold front tied to the cyclone in Hudson Bay. 57 at Ironwood, 43 near Marquette. Dew point drop of 11 degrees, precipitation and fog on the other side. And the same across the state of Wisconsin. We're on the warm side at 15Z. We may be right about at it now because there's no development going on here, which is going to make slow progress to the east. And then across Iowa, you can see the frontal boundary all the way down into Kansas. This station's just about to meet its fate. 75 with a southerly wind right on the front. It's going to be in the 40s in a couple of hours. And then this green of the isobars every 4 millibars. This is 1,008, 1,012, so I've only done 2 of them. But that's to show that the front lies in a pressure trough. It really does. But it's not really associated with much development. This little 1,008 and lower is associated with the storm to the north. And here's where the new thing is developing over Texas. Meanwhile, the precipitation band is right along the mid part of the front. You can see it reflected in the surface obs. Light rain, heavy and moderate rain, moderate thunderstorm with 39 over 38. That's a place to be. And then when you get into Texas, light snow in Amarillo, 37 over 27. Outstanding, isn't it? And then same in northern New Mexico, moderate snow in southern Colorado. Yeah, now we're talking. Okay, so that's a nice picture. And then if you put the satellite on top, as best you can, they're on different projections, so I matched them on the states that matter. There's where it's precipitating, and it's perfectly aligned with what we see in the satellite. I mean, in the surface obs. So that's kind of neat. We do all these things. Okay, the next thing is, let's take a look at what develops. What is the thing that's going to develop this cycle? Okay, and to do that, I know you're all going to laugh at me. I'm a dinosaur. I'm using the nested grid model, North American model, to do this. The reason why Pete knows already, this is the 500 millibar vorticity from the 12Z forecast of the NAM, valid at 18Z right now, so it's valid right about now. This is a beautiful, smooth picture of what we see. Okay, the high resolution stuff that you can get on Tropical or you can get on Pivotal, they're great. Because that's, but if you want to abandon your diagnostic instincts and just trust the black box, use those. If you want to try to understand what's going on and then use those with a little bit more informed perspective, use something that's a little bit smooth. And the smoothing is a result of the lower resolution. But anyway, here's the 500 millibar vorticity, absolute vorticity. Beautiful things that you see here that are really quite spectacular. First, a strip of really intense upper vorticity. That is pretty much along the line we saw at 500 millibars where the barotonicity is strongest. Even though it's fairly weak at 500, that's where it's strongest. And then here's a little strip from the northern part of our own state into central Kansas that is, well, actually negative absolute vorticity. So how do we get that? The guess is that you have ascent in the mostly convective rain band that we saw. Maybe on the radar, a lot of it was convective. You're probably taking potentially unstable air, that is D, theta, DZ is negative in the boundary layer, and lifting it up in the updrafts, and when it gets up to this level, there's no longer any chance that d theta EDZ is negative. Instead, to conserve the moist PV, you've got inertial instability, which is absolute negative vorticity. So I think that's what's going on here, but you see a really nice correlation spatially between where there might be negative absolute vorticity and where the radar reflectivity is convective in this event. So that's kind of cool. But the biggest thing is, here's a giant vorticity maxima on the order of 3.5 times F sitting in far southeastern New Mexico. Okay? And you can page back and forth between that image. I will put my pointer right there. This is stretching the limits. I can't do it, but you'll see what's going to happen. Here's the, well, you should see what's going to happen. Come on, where's my cursor? Damn cursor. Get it? You don't get it. There's where we were, right? And here's the 1,000 to 500 thickness. Thermal wind is really strong with the thickness gradients large. Right down sheer of that in the panhandle area of Texas, that's where you have your strongest PVA by the thermal wind. Cyclone is beginning to develop in central Texas, but look at this little bulge of lower pressure, seemingly paying attention to where that development region is. Here's our precipitation forecast. That's exactly where the negative absolute vorticity was. Keep your eye on that spot, and I'll bounce back and forth for you. There's almost no difference in the spatial location of those two things. So there's a lot to see in this single pair of images. Let's go ahead 12 hours. So I'm going to go to 18 for the surface, and I'm going to do the same when I go to the 500. I can't read with these glasses, I'm sorry, it takes me a little bit of time. But here's 18Z, our 18-hour forecast, so this is valid tonight at midnight. The strong upper vorticity feature that was down in southeast New Mexico has progressed to the north and east, and it's kind of wrapped up a little bit. It's still tied to this strip that comes down from the prior cyclone, but this is the main event. Here's where the convective line may well be when we see the forecast, and a little bit more of it right here. So the maximum vorticity is in sort of northern central Oklahoma and then into southeast Kansas, right in this region here. Let's see what the surface map looks like. So remember, it was right about here was our maximum vorticity, and there's a strong thermal wind indicated by the tight spacing of the thickness lines, and look where the cyclone's developing, right in the same location, okay, or just a little to the west, and the pressure has gone down a little bit now. Our heavy convection is all the way from Green Bay down into western Missouri, and then along the strip. It's still precipitating because that's still a frontal zone, and it's probably an active frontal zone. One can see that there's a little bit of differential temperature convection astride the thickness contours, and so that's right where it should be. Everything's exactly according to theory. It's so nicely illustrated on maps that have relatively low resolution. So let's go another 12 hours ahead. So that's going to be for the 850 for the 500. I've got to go do that one next. 30 hours. So by the time we get to midday tomorrow, we've got a vortex strip that has a different orientation than it did just 12 hours earlier, and now it's stretching from sort of central Wisconsin all the way back down to central Missouri and along the Mississippi River in the middle of that. So that's going to be the feature of interest for any more development we might see of the cyclone. But we have strips of vorticity like that, and this one here. They may be foci for the production of precipitation for reasons that are actually not related to the vorticity advection, but just are structurally coincident. So here's the surface analysis. Remember, our vorticity strip was right about in this location. Once again, thermal wind is really strong there. So on the northern end of that strip, which was in the central and northern part of our state, that's where the PVA by the thermal wind will be largest. Look at this weird precipitation blob that shows up there. It's not really tied to the fronts, which are in this location. You can see here's the frontal precipitation over the southeast. Here's the frontal precipitation along the warm front. This blob back here is not really tied to those two frontal structures, but it's clearly tied to the PVA by the thermal wind. And that's also fueling the development. We're down to 990 millibars here. So we're going to have gusty winds during the football game tomorrow while it's raining fairly heavily. Okay, so it's going to be a really stormy sort of day. And this cyclone started out 1,008 millibars, maybe, just 24 hours ahead, which is right now here in central Texas or West Texas, and it's been picked up by this upper level wave, and the PBA by the thermal wind has developed it. The frontal structures have remained active and forced by horizontal frontogenesis to produce precipitation bands. So you can see all these things at the somewhat lower resolution here. And I guess we'll go one more time. That'll go out to 42 hours. No, I want to go to 36. It's a little more interesting. Yeah, that's good. And then I'll go to the other one at the same time, and we'll try and do this one last time. So here's the 36-hour, 500 millibar vorticity forecast. So this is for tomorrow night after Maryland is sent to the airport in a disgusted mood. Here's the maximum vorticity right over Washington Island. And the gradient from high to low is across southern Lake Superior. So we're going to pay attention to this portion of the vorticity, because presumably the thermal wind is headed northward, and so it'll be positive vorticity convection in that region if that turns out to be the case. So let's see, right there near Ironwood, Michigan, and right in that location, thermal wind is reasonably strong, weaker than it's been, but nonetheless, that's where we're seeing another of these weird precipitation bands to the west of the cyclone. That's I think responding to the now weaker PBA by the thermal wind. Cyclone's deepened by 3 more millibars in just this time, I think 6 hours. So a pretty decent development that one can actually make sense of with a fair degree of accuracy here by using some old tools. Not only the way the maps are shown, but also some old diagnostic tools. I had another thing I wanted to show you, which was the, I don't know if I have it easy to find here on my screen. Yeah, here it is. So here's the vertical motion diagnostics that I calculate every day. Now this is from 0Z last night. So to get to that time, we have to go all the way to the end. But we'll go to the current time, which from 0Z last night would be an 18-hour forecast. And here's what the 700 millibar quasi-geostrophic omega shows for right now. Strong subsidence down over the panhandle of Texas, strong ascent, well that's the western panhandle, and then the northern panhandle is where the ascent is. So this couplet is related to the development we're talking about. And then see the ascent spreading all the way toward Green Bay, but weakly, that's the frontal portion of it, and I can prove it by showing the split between the along and across isentrope Q vector. So here's the along isentrope Q vector vertical motion. This is effectively the Sutcliffe development theorem, but not quite. And that is limited to just the development part. Nothing that extends up toward Green Bay. And then if you look at the transverse part, remember we were talking in class this week about when the Q vector crosses the isotherms, it produces couplets of vertical motion. My contour interval is a little bit weak, but you can see there's some vestige of that in the frontal region. These are every one. If I could have increased them, then you'd see it even more vividly. But it's also true that the quasi-geostrophic frontogenesis is not as good at picking up the total frontogenesis, but it's the only one that allows us to diagnose the vertical motion directly. So we have to make a compromise there. Okay. And then maybe we'll go ahead a little bit into, what time is this going to be valid? This is, no, we'll go to noontime, end of the day on yeah, tomorrow at noontime, this is the forecast. So that couplet of vertical motion that started down here is just making slow but steady progress to the north and east. And by the time we get to noontime tomorrow, a lot of air is being pumped out of the column in northern Wisconsin. The cyclone's down around 990 millibars, and it's going to be intensifying even further, and so the winds will just be really strong, whipping around. And you can see, not only is there another cyclone upstream, but there's now a little bit more obvious extension along the warm front and some extension of the ascent along the cold front. Let me show you that one last thing. That was at 48 hours, was it?
42.
42, was it? Yeah, 42. So there's just the development part. It doesn't have any of the extensions, and I think that the transverse does. Yeah, you can see a little bit of the frontal structure. There's the warm front, ascent with the warm front, and ascent with the cold front. It's admittedly weak. That's a handicap of the formulation itself. There's no way around that. But it does show a separation between a development couplet that we saw in the prior image, and then these are the responding transverse vertical motions that are tied to the fronts. And so you can kind of start to see a structure emerge. The same true with the upstream cyclone. Here's the cold frontal ascent and a little bit of the warm frontal ascent. Descent on the cold side of the warm front, really nice. Okay. So I think that's all I have for today, since the weather tomorrow and Sunday is really high impact compared to what we've recently experienced. It's going to be raining, sometimes heavily, over the next 36 hours. I would guess we have a chance at an inch or more of rain by the time it's all over. And that's unusual. We haven't had many such days. Even through the summer, we didn't have many such days. We had the one on September 11th, which was really rainy, but that's about it that I can recall. So it's been a relatively moderate to heavy rain free last 6 or 7 months, but that ends this weekend. Okay. And I should say, I'll just say, I won't show you, next week we rebound into temperatures in the 60s by the middle of the week. We're going to be 65, 66 on Wednesday and Thursday, but I think that will be the end. Because a cold front that comes through Thursday into Friday drops the temperatures in a day down to the mid-40s for highs. And by that time, we're November 11th, I don't think you have any reasonable expectation that we see 70 or near 70 ever again until late April or May. It just isn't going to happen, so you should prepare yourselves for that. And then the next quest is, when do we get our first measurable snow? And as far as I can see, and I'm the most optimistic looker at these weather maps that anybody in this room, I still don't see it in the near future, so that's to be seen. Kayla.
If you do want to see a fun forecast, go to the Canadian model, 180 hours in forecast.
How do I do that?
Tropical Tidbit says,
Okay, forecast models.
go to global, should be CMC. Yeah. Go to our, like, 1 week.
Okay. Okay, so now we're talking. This is Saturday, Saturday the 12th of November. That would be really nice, wouldn't it? It'd be really nice. What an interesting, if this happens, what an interesting storm. You've got primary cyclone, perhaps redevelopment along the Appalachians, kind of a classic wintertime setup, and cold enough here to snow, so that's great. Thank you for pointing that out. But let's keep our eyes on this. A week from today, we'll know whether or not this has any chance of being real. And it could be really fun talking about the weather next Friday, if it is. All right, so I guess we'll see you all next week. Have a good weekend, enjoy the football game, and bring an umbrella. So.